Assalamu alaikum. Welcome to my video series on data science. Today we will extend our discussion on machine learning towards unsupervised learning methods. Clustering is a powerful technique used to group similar data points together. In this video, we will explore different clustering algorithms to learn their working using several examples. Clustering is a type of unsupervised machine learning techniques used to group a set of data points into clusters such that the objects in the same clusters are more similar to each other than those to other clusters. In clustering, the goal is to minimize the intra-cluster distance and maximize the inter-cluster distance. Clustering algorithms are divided into three categories: partition-based, hierarchical, and density-based clustering. Partition-based clustering divides the data into non-overlapping clusters. Each data point belongs to exactly one cluster. Examples include K-mean, K-Medoid, Clarence, etc. Hierarchical clustering creates a tree of clusters called dendrogram, where each data point starts as its own cluster and clusters are merged or split based on similarity. Examples include agglomerative and dimensive clustering. Density-based algorithms form clusters based on areas of high density, and it can detect clusters of arbitrary shape. Examples include dbScan, optics, DenClue. In this course, we will explore three techniques: K-means, K-Medoids, and agglomerative clustering. Let's explore K-mean clustering as a prime example. K-mean works by iteratively assigning data points to the nearest cluster centroids and then recalculating the centroids. Here we have 8 data points and 2 features. We need to group them into 3 clusters. So step 1 is to randomly choose 3 centroids. We can choose any random data points from the dataset. So point 1 has been chosen as centroid 1, point 5 as centroid 2, and point 8 as centroid 3. Now the next step is to calculate the distance of each data point with these centroids. The distance matrix that we will use will be Euclidean distance. For example, if we want to find the distance between the first point and the first cluster center or centroid, so this would be the formula. Since the first point and the C1 both are the same, so we will subtract the corresponding values, 2 minus 2 and 5 minus 5. We will get 0. Similarly, if we want to calculate distance between the first point and cluster center 2, point 1 is 25, cluster center 2 is 415. So we will subtract the corresponding values, 2 minus 4 and 5 minus 15. We will get 10.198. So we will repeat this process for all data points. So we calculate the distance of each data point with each cluster center, C1, C2 and C3. And we create a table like this. Now we need to see the minimum distance of these points with the cluster centers. So the first point is itself a cluster center, so it is 0. The second point has minimum distance with C3, that is 4.47. The third point has the minimum distance with C1, 3.16, and so on. So based on these distances, we will assign each data point a cluster. And this assignment will be based on the minimum distance to the cluster center. So the first point has minimum distance with C1, so it will go to C1. The second point has the minimum distance with C3, so it will move to C3. The third point has the minimum distance with C1, so it will move to C1, and so on. So after completing this process, we will get these clusters. So one cluster contains 1, 3, 6, and second cluster contains 2 and 8, and the third cluster contains 4, 5, 7. So after one iteration, we have these clusters. Now we need to calculate new cluster centers. And to calculate new cluster centers, we need to add the corresponding x and y values of the points of each cluster. For example, in cluster 1, we have point 1, 3 and 6. So 1, 3 and 6, we will add the x values of 1, 3 and 6 and divide by 3 because there are 3 number of points. So actually we are calculating the mean of x and mean of y. So point 1 has x1 value 2, point 3 has x1 value 3, and point 6 has x1 value 5. So we'll add the corresponding x values and then divide by 3. So we will get 3.33 the x value of the new cluster center. Similarly, we will take the y values, add them up and then divide by 3. We will get the y value 6.67. So now the new cluster center is 3.3 and 6.6. Similarly, we will compute the cluster centers for each cluster. So now we have cluster centers for C1, C2 and C3. Now using these updated cluster centers, we will repeat one more iteration and calculate the distance of each data point with the cluster centers. After doing this, we will assign each data point a cluster from which the distance is minimum. After completing the second iteration, we can see that there is no change in the number of elements of the clusters. So this is the stopping criteria. If the elements in the clusters do not change in 2 consecutive iterations, we stop the process. And if they change, we will again update the cluster centers and repeat the process. Now we will discuss K-Medoid clustering with the same data example. Step 1 in the K-Medoid clustering is the same as in K-means clustering. We set the value of K and randomly select 3 cluster centers. In K-Medoid clustering, we don't call them cluster centers or centroids. We call them medoids. Next step is to calculate the distance of each data point with the medoid. So this is almost the same step. The only difference is that we will not calculate any distance with the medoid points. So you can see that there is no distance calculated for M1, M2 and M3. So after calculating the distance, we will assign each data point to a cluster based on the minimum distance. So after the first iteration, we have got these points in the cluster 1, 2 and 3. Please note that we have not written the medoid points because we need to calculate the cost. So it's an additional step in K-Medoid clustering where we calculate the cost of clustering. Cost for each cluster is calculated and then we sum all the costs of all the clusters. For example, in cluster 1 there are 2 points 3 and 6. So we will check what is their minimum distance to M1. So it is 3.16 and 3.61. So we will add them up and then we will look for C2, 4 and 7. Minimum distance to their respective medoid is 2 and 5.1. So we will add them as well. Similarly for the last cluster. So we have the cost 18.34. Now we take an assumption that the medoid formed in the previous steps are not correct and we will randomly change a medoid with a non-medoid point. So let's say we change M1 to second point from the first point. So now the new medoid point is 210. We will again calculate the distance of each data point with each medoid and then assign them the clusters based on the minimum distance. So these are the final clusters we have. Please note that the medoid points are excluded. So now we will again calculate the cost. So after calculating the cost, we got 18.58. Now the next step is to compare the new cost with the previous cost. So the previous cost was 18.34 and now the new cost is 18.58. So if the new cost is greater than the previous cost, it means we can now stop and we can revert to the previous clusters and previous medoids. If the new cost is less than the previous cost, it means that the new clusters are better. We will now replace any medoid point with a non-medoid point and repeat the process again. In our case, the new cost is greater than the previous cost, so we will stop and revert back to the previous clusters. So our final clusters are cluster 1 contains 1, 3, 6, cluster 2 contains 5, 4, 7 and cluster 3 contains 2 and 8. So summing it up, we have discussed centroid and medoid representation in K-means and K-Medoid clustering. K-mean uses the mean of cluster points as the centroid, which can be heavily influenced by extreme values or outliers, whereas K-Medoids use an actual data point called medoid to represent the cluster center, making it less sensitive to the outliers. That's all for today. In the next lecture, we will start with the agglomerative clustering. If you found this video helpful, don't forget to like, share and subscribe for more videos on data science and AI. See you next time.